Determining the candidate and viable function. The first step of function matching identifies the set of overloaded functions considered for the call. The functions in this set are the candidate functions. A candidate function is a function with the same name as the called function and for which a declaration is visible at the point of call. Okay. In this example, there are four candidate functions f. Right. The second step selects from the set of candidate functions those functions that can be called with the argument in the given call. The selected functions are the viable functions. To be viable, a function must have the same number of parameters as there are arguments in the call, and the type of each argument and okay, to be viable, a function must have the same number of parameters as there are arguments in the call, and the type of each argument must match or be convertible to the type of its corresponding parameter. Okay. We can eliminate two of our four candidates based on that. Okay. So this is gone and this is gone. Then we have these two. We can eliminate two of our candidate functions based on the number of arguments. The function that has no parameters and the one that has two int parameters are not viable. Oh, okay. So we called it with 5.6, right? Okay, so this is not viable and this is not viable. Then we have this, right? Okay. A call has only one argument and these functions have 0 and 2 parameters respectively. The function that takes a single int and the function that takes two doubles might be viable. Either of these functions can be called with a single argument. The function taking two doubles has a default argument, which means it can be called with a single argument. When a function has a default argument, a call may appear to have fewer arguments than it actually does, right? Having used the number of arguments to winnow the candidate functions, we next look at whether the argument types match those of the parameters. As with any call, an argument might match its parameters either because the type matches exactly or because there is a conversion from the argument type to the type of the parameter. Okay. So, so in this example, both of our remaining functions are viable. Fint is viable because a conversion exists that can convert the argument of type double to parameter of type int. Then double is viable because a default argument is provided for the function's second parameter and its first parameter is of type double, which exactly matches the type of the argument in the call. If there are no viable functions, the compiler will complain that there is no matching function. Okay. Finding the best match, if any. The third step of function matching determines which viable function provides the best match for the call. This process looks at each argument in the call and selects the viable function. Odd functions. This process looks at each argument in the call and selects the viable function or functions for which the corresponding parameter best matches the argument. We'll explain the details of best in the next section, but the idea is that the closer the types of argument and parameters are to each other, the better the match. Okay. In our case, there is only one explicit argument in the call. That argument has a type double. To call fint, the argument would have to be converted from double to int. The other viable option, f double is an exact match for this argument. An exact match is better than a match that requires a conversion. Therefore, the compiler will resolve the call as a call to the function that has two double parameters. The compiler will add the default argument for the second missing argument. Alright. Then we have function matching with multiple parameters. Function matching is more complicated if there are two or more arguments given the same functions named f. Let's analyze the following call. Okay. So we have f42.56. The set of viable functions is selected in the same way as when there is only one parameter. Okay. The compiler selects those functions that have required number of parameters and for which the argument types matches the parameter types. In this case, the viable function matches are int int and double double, right? The compiler then determines argument by argument which function is or function are best match. There is an overall best match if there is only one in. Okay, there is an o. What the If after looking at each argument there is no single function that is preferable, then the call is an error. The compiler will complain that the call is ambiguous. Okay, in this call, when we look at the first argument, we find that the function f int int is an exact match. To match the second function, the int argument must be converted to double. A match through a built-in conversion is less good than an exact one. Considering only first argument is a better match than this. Okay. Then when we look at the second argument, it's an exact match to the argument 2.56. Calling f int int would require 2.56 be converted from a double to int. When when we consider only the second parameter, the function f double double is a better match. The compiler will reject this call because it is ambiguous. Each viable function is a better match than the other one on the argument to the call. It might be tempting to force a match by explicitly casting one of our arguments. However, in well-designed systems, argument cast should not be necessary. Right. Okay, cast should not be needed to call an overloaded function. The need for a cast suggests that the parameter sets are designed poorly. Okay, then we have what is a candidate function and what is a viable function. So a candidate function, there we go. The first function identifies a set of overloaded function. Consider the call. Okay, set of overloaded function and viable function. The second step selects a set of candidate function, those functions which can be called with the arguments in the given call. Okay, so candidate is set of all match set of set of overloaded functions, and viable function is that candidate function that 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 can be called with the with the with the provided arguments either directly or through conversions. Okay, then we have given the declaration of f from page, yeah, list the viable functions if any. Okay, so I can write, we have a, so viable is int and f double double. Then we start with B, so if int is viable and C viable, right? So it'll go int and F double double, and same for D, right? Hmm. So to be viable function, a function must have the same number of parameters and as there are arguments in the call, and the type of each argument must match or be convertible to the type of its corresponding parameter. Okay, so I can say same for D. Same for D. Write all four versions of F. Each function should print a distinguishing message. Check your answers for the previous exercise. If your answers were incorrect, okay, write all four versions of F. Okay, we can get started with that. CD2 exercises. I want to make a directory. This is 6.6 called section 6.6. Then I want to create a new file which is 6.5 6.51.cpp. We will zoom in a little. Let's include IO stream. Reading this declaration from the inside out, we see that f1 has a parameter list, so f1 is a function, right? This is a function. F1 is preceded by star, so F1 returns a pointer. Okay, so it is preceded by a star, so it returns a pointer. The type of that pointer itself has a parameter list. Pointer itself has a parameter list. So the pointer, so so the pointer points to a function. This pointer points to a function. That function returns an type. For completeness, it's worth noting that we can simplify declaration of functions that return pointers to function by using trailing returns. Right. Okay, so this is easy. Okay, using auto or declare type. Okay, this is a little bit confusing. So fn, okay, fn is a integer, fn is a function, pf is a pointer to function, and fn returns a pointer to function. Then f is a function type, fn can't return a function. Then explicitly specify that the return type is a pointer to function. Using auto or declare type of function pointer types. Using auto or declare type for function pointer types. If we know which functions we want to return, we can use declare type to simplify. We can use declare type to simplify writing a function pointer type return. If we know which functions we want to return, we can use. For example, assume we have two functions, both of which return a string size type. Right. Okay. And we have two const string parameters. We can write a third function that takes a string parameter and returns pointer to the function for these two functions. Huh. The only tricky part is declaring get function is to remember that when we apply declare type to a function, it returns the function type, not a pointer to function type. We must add asterisk to indicate that we are returning a pointer, not a function. Okay, so this is the last exercise that I would have to complete. Right, I can close this. We will create a new directory, say section 6.7, section dash 6.7. I want to then I want to create a new file. Write a declaration for a function that takes two int parameters and returns an int. Declare a vector whose elements have this function pointer types. Okay. So this is 6.54 and 6.554.cpp. Right. So let's int type some int and int. I believe this is write a declaration for a function that takes two int parameters and returns an int, right? And declare a vector. Okay, so I also need a vector. So we have okay. This is our function, right? Then our function pointer, right? Okay. So then we have our function pointer. So I can write it as int function pointer takes two arguments and that is it. Then I can create okay, let me close this. Then I can create a vector. Okay, but I would need the type, right? Okay. So I can go using fp equals to this function pointers, right? Then I can go type fp and I can say func vector. Right. I have type def, or I could have used a type def, right? Uh, how could I have used a type def? Another way. Mm, another way is type def. We go int, right? Int, int fp, and I just go like this. Do I have to? Okay. Let me see. Yeah, using we can a function type, a function pointer. Then we have type def. We can declare right directly. Yeah, like this. Okay. Another way is this. Then but I'm not really okay. Do I need to push it? Okay. And declare a vector whose element. Alright. Write 4 functions that add, subtract, multiply, and divide 2 int values. Store pointer to these functions within a vector from previous exercise. Call each element in the vector and print their result. Okay, so I can just combine it into a single exercise. Okay, and another way is up. Okay, yet another way using tickle type would be say I would write type def tickle type. I would go sum, and then when we create a function pointer, right? Okay, then okay. Okay, so I have this let's say right 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 so I can write 4 functions, right? Int sum and int b, and I can return a plus b. And I can subtract, so int a, int b, and I can return a minus b. Then I can have int multiply, and int b, we can run a times b, then we have int divide and a, int b, and then we can return a divided by b. Right. Okay. Okay. So right. So I can push these. Let's say. Okay. I should compile the program first. Right. Right. I would like the. Okay. So we can simply push these. We can push these. Dot. Get back to this push back. I can push in addition. How can I um, paste, paste, and paste? Okay. This is not the start of a word, is it? Okay, so we put subtract, then we will go down. How do I go back? Okay, then we will put in multiply. Then we can put divide. Right, right. Let's try this works great. Right. Okay. Then what I can do is I can call each of the vector can call each of the vectors say func print line addition of say 4 and 2. Okay, addition of 4 and 2. I can just write something like that, and then we can call func vec of 0, and then we can pass 4 comma 2, and yeah. Okay, now no, I don't want to do that. Why does it why does it take? I don't understand. Alright, so I want I'll write difference. Right. Uh, 1. Then we can go. This is 2. Then this is 3. Right. Okay. So I want last one is division, then addition, difference, and then we have multiplication. Right. Then we can save, and then we can okay. Yeah, no. Print line is not a member of std. Oh, my bad. I wish to fix print. No, this is okay. It is this extra. I want to select how do I. Okay. Now it should work. Yeah. A dot out, and there we go. Addition, difference, multiplication, and division. Great, 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 great. So this is done. I want to test it with the other ones as well. Right. Okay. So I can comment it out. Then I can go down and I can uncomment it. It should still and it should still work. Right, a dot out, yep, still works. Then we go here and I can again comment it out, but I would okay, so I can make it, but I would have to be a little yet another way. So I can go type tab. We can take the type information from, let's say, addition, and we can create a pointer called FP. I can just run this command. Okay, great. Alright, so decal type returns the function type. We have to explicitly convert it. We have to explicitly convert it to a pointer, to a function. Right, that is it. Okay, so I am finished.